So we're going to look at 2, 3, and 4. And on these, we're going to be combining everything that we've learned so far together. So we might be adding, subtracting, and at the end, multiplying and dividing. So let's look at some of these. And let's talk some more about these fractions. We covered these a little bit before break, but I want to review them again. So now let's go to page 130. And let's talk some more about fractions and how to clear them out. And let's look at question 29. On question 29, we've got 3 over 4z plus z over 3 equals 13 over 2. Now we're going to apply the exact same properties and principles that we did a moment ago. We need to clear our fractions. So what do we have for our denominators? We have a 3, a 4, and a 2. So let's take the 3 and the 4. What's the least common denominator of 3 and 4? 12. Now, does 12 cancel out with that 2 as well? Yes. So we can multiply everything by 12, and that's going to clear out again all of our fractions. So multiply everything by 12, and it's going to clear them all out. Now let's really take our time and make sure we know how to clear these fractions. So what's our procedure? Divide by the number down below, multiply by the number on the top. So we've got 12 divided by 4. Okay, 12 divided by 4, that's a 3. 3 times 3 makes it a 9, and we bring our z down. Next, 12 divided by 3. Okay, 12 divided by 3 is a 4. 4 times z, that leaves you with a 4z. Don't forget the other side. 12 divided by 2 is a 6. Okay, and we may need a calculator here. So 12 divided by that 2 is that 6, times that 13, that gives you a what? 78. Now, what techniques can we use next? These have to go together. They are like terms. 9 and 4 makes it 13z equals that 78. And what's going to be my last and final step here? Okay, divide both sides by that 13, and let's see if it comes out evenly. And it does, okay, because 78 divided by that 13, that comes out to now be a what? 6. So what's my final answer here? Z equals 6. Okay, we're going to add more fractions now. How about 38? We have to get used to clearing these fractions out. And we've got 1/5 x minus 2/3 x minus 2 equals minus 2/5 x. Okay, so what do I need to do? I need to clear my fractions, and I have a 5 and a 3 down below. So the least common denominator of 5 and 3 would be a 15. So this one's going to require us to use multiple properties. So the first thing we'll do is we clear the fractions, unless they all go together. And these really don't go together. I mean, I could move that over, but we have several fractions, so let's just get rid of them. And we draw the arrows. I think the arrows make sure you don't miss something, right? So I always draw those. Now, what do? Divide, multiply. Divide by the number down below. So 15 divided by 5, that's a 3, right? Okay, and 3 times that 1 makes it a 3, and bring down your x. Next, 15 divided by 3, that's a 5, times a negative 2 makes it a negative 10x, right? 15 divided by 3 is 5, times that negative 2 makes it a negative 10. Bring your x with it. What about here? There's nothing down below, so we just multiply. 15 times a negative 2, that's a negative 30. The other side, 15 divided by 5. Well, 15 divided by 5, that's a 3. Okay, 3 times a negative 2 makes it a negative 6x. Is everyone okay now with how I cleared those fractions? Fractions are the ones where students struggle the most with. Decimals, students are okay with. It's fractions. And we are going to learn how to get rid of them at the very beginning. Anytime we have an equal sign, from now on, we get rid of our fractions, unless they all go together easily, and these do not. Okay, now, let's combine some terms together and see what we are working with. Well, we have a 3 and a negative 10x. Those can go together. And that makes it a minus 7x and a minus 30. And that equals that minus 6x there. Okay, because those can go together. Now, I'm going to move that negative 6x over. Okay, so we're going to be trying to get the x's together on one side. And you can do this a couple of different ways. I always like to, in this course, until you get used to working with things, move all the variables to the left, numbers to the right, even if that makes an extra step or two. It's just easier, I think, for us to get in that habit. Once you get some more advanced skills, you can do other techniques. But what I'm going to do is I'm going to move that 6x over. Now that 6x is a negative 6x, so you would move it over with a positive 6x. Okay, so that's going to go away. Minus 7x plus 6, that leaves you with a minus x, and then we've got a minus 30. Now, if it all goes away on the right-hand side, we're going to leave this equaling 0, because those went away. Okay. Now, I could have moved it to the right, but I think that's confusing for us right now. I would rather us, for right now, move all the variables to the left, numbers to the right. That way we don't have to worry about switching things around yet. So now what are we going to do? Okay. We should know what to do. What's my next step going to be here to finish this out? No, we're not going to divide. Okay, so let's talk about why we're not going to divide. That 30 is not in front of that x, is it? Right? If it's in front of the x, that means it's multiplied. Where is it? It's subtracted off at the end. Okay? Because it's that x minus 30. So that's a minus 30. So how do we get rid of a minus 30? We have to do what? Add 30, right? That way it goes over. You only divide by numbers that are in front of the x, directly in front. And so there's nothing in front. Now those cancel out, okay? And that leaves you with a minus x equals now 30. We do not want it to be a negative x. We want to make sure it's a positive x. And I know we did one of these earlier. How do we get rid of the negative? Divide by a negative 1. That takes care of the negative. Because a negative divided by a negative makes it a positive. Negative and negative makes it a positive x. And 30 divided by a negative 1, well, that leaves you then with a what? Negative 30. So your answer on that one would be negative 30. Let's try another one. Question, how about question 41? So question 41, we've got 2/3 w plus 4 equals 2/3 times W plus 3 plus 2. Okay, now, when we see a question like this, what do we need to do first? Well, we always go back to our order of operations. And what's the first thing in the order of operations? Parentheses, right? So the first thing that we need to do is get rid of these parentheses. And how do we do that? We use our distributive property. And if you struggle with the fractions, write them over to the side. So we're going to distribute this through first. We cannot clear the fractions until all of the parentheses are gone. So the first thing we're going to do is distribute that 2/3 through. So 2/3 times W, well, that's just a 2/3 W. If we struggle with the next piece, which is 2/3 times 3, we're going to write that 3 as a 3 over a 1, and then we can cancel, and that leaves me then with a 2. Because I wrote that 3 as a 3 over 1, and that can cancel with what's down below, and so that leaves you then with a plus 2, and then another plus 2 from there. Okay, so that came down. Now this introduces another concept here. Normally we get a solution. This one's not going to give us a solution because let's talk about what's going to happen when I combine like terms together. When those go together here, what does that give you? That gives you 2/3 W, and then 2's added together, that gives you a 4, and look at the other side. The other side is the same, okay? Now, this is a little bit different from some of the others. Notice these are exactly the same. When they are exactly the same, we have a special name for it. We call it an identity. Remember identity when we looked at those properties? Right? Remember last time when we looked at the properties in 1.7 and 1.8. When we talked about the identity means they're the same. If the left and the right are exactly the same, then it is called an identity, and the solution set is all real numbers. And what that means is any number that I plug in there is going to work every single time. I can plug in a 5. Okay, if I plug in 5 here and 5 here, they're going to be the same. Right? These are exactly the same. So whatever variable or value I plug in for W, it's always going to be the same. So if the sides are exactly the same, it's called an identity, and the way I remember that is I think of identical twins. Right? Identical twins are the same. This is an identity. It means the sides are the same. And whenever you have an identity, your solution set is all real numbers. Okay, because the sides are the same. Now, the opposite of that is no solution. So let's look at one that has no solution now. And that was question 41. Let's go back and look at question 40. That one was an identity. Question 40 is what's called a contradiction. And we'll see why this one doesn't work. Okay, I wanted to do the identity first. That's why I chose 41 first. So you'd see they are the same. Okay, question 40 is going to have no solution. And let's talk about why this one has no solution. Well, the first thing I should do is clear out my fractions. And least common denominator of 2 and 5 is going to be what? 10. So I'm going to have to multiply everything by a 10. Where students tend to make mistakes is you get in a hurry and you rush through things. Take your time. Don't try to go through things too quickly. If you make mistakes, you'll get frustrated, and it'll take you more time than if you just slowly go through the steps. I draw the arrows. I like to make it very detailed so I don't lose track of what I'm doing. So I'm clearing out these fractions. So I'm going to go through each one individually, divide by the number down below, multiply by what's on top. So 10 divided by 2, well, that is a what? 5 times 1x makes it a 5x. 10 divided by 5, okay, 10 divided by 5, that's a 2, times a negative 1 makes it a minus 2x there. Then we've got 10 times 1, that makes it a 10. 10 and the 10 below, those cancel, and that leaves you with a plus 3x. Is everyone okay with that so far? Now, what's our procedure? What do we do? Before we move things across the equal bar, what do we do first? Combine like terms. So these 5x and the minus 2x, well, those can go together. That leaves you with a 3x equals now 10 plus 3x. Okay. Now, what's my ultimate goal? To get all the x's on the left-hand side. So that's what I want. Now, this one is a little bit different because when I move that 3x over, all right, it's going to cancel out with the other one. So let's move that 3x over. Now look at what happens. The positive 3x and the negative 3x, they cancel, and that leaves you 0 on the left and a 10 on the right. How is this one different from all the others? Okay. Well, in this one, the variable x is gone, isn't it? Okay, so the variable x is gone. This is not an identity because they're not the same. If this would have been a 10 here and a 10 there, then it would be an identity. But this is not an identity. The variables are gone. Does 0 equal 10? No, 0 does not equal 10. This is called a contradiction. Because 0 cannot equal 10. It's a contradiction. And for contradictions, you have no solution. And the way I remember it is I think of it as a false statement. 0 cannot equal 10. That's a false statement. It's a contradiction. And remember, what do we know about giving contradictory testimony in a court of law? If I give a contradictory testimony in a court of law, that means I lied or I gave a false statement. Can't happen, right? You're not supposed to lie in court. That's why this has no solution. It's false, and it's called a contradiction. So it's a contradiction, and it has no solution. Why is it like that? Because the variables canceled themselves out. And that doesn't happen that often, but once in a while it does happen. So if the sides are exactly the same, that is an identity. Think of identical twins. Same. If the variables cancel out, you're left with something that doesn't work because 0 does not equal 10. That's a contradiction, and it has no solution. The other ones are called conditional. We don't really name them that often. We just solve them. Okay, so we're now going to look at some where we get answers again, and then we'll look at some more identities and contradictions later on. Well, let's look at another one where we get a solution. How about question 47? This one's going to give us a solution. And we've got 1/2 times x plus 2 plus 3/4 times x plus 4 equals x plus 5. Okay, so order of operations. What do we do first? Parentheses. So the very first thing that we need to do is we need to get rid of these parentheses. And sometimes students struggle with where to stop. This 1/2, we distribute it through, and where does it stop? At the 2. Then we've got this 3/4, and it stops at the 4. A lot of times I've seen students try to take the half through everything. It doesn't. If you need to make the parentheses bigger at the end so you know when to stop, you can do that until you get used to doing it. Now we're going to distribute through, and we're going to see what we have. Half times an x, well, that's easy because that's just 1/2 x. Okay, then we've got a half times 2. So I'm going to write that 2 as a 2/1. The 2's can cancel, and that leaves me with a 1. So that's going to be a plus 1 there. Next piece, 3/4 x. That comes through. And what about here? We've got 3/4 times, that's a 4. We're going to make that a 4/1. And what can happen with the 4's? Cancel. And so what's left over then? Yep, that gives you then a 3, doesn't it? Is everyone okay with that? So we just canceled out there, and 3 times that's going to give you 1 there. Those cancel, so that gives you a 3. Nothing down below. And the other side is an x plus 5. Now we're going to clear out our fractions. We could combine things together. We could put the 1 and the 3 together. Might as well just go ahead and get rid of the fractions now. I think it's going to be easier that way. And so what would we need to multiply everything by to get rid of our fractions? Does anyone know? Okay, we've got a 2 and a 4, so we're going to multiply everything by a what? 4. That's going to clear them out, won't it? Least common denominator, 2 and 4 is a 4. Draw your arrows and take your time here. Let's see what we're left with. 4 divided by 2, that's a 2, times 1, that makes it a 2x. 4 times 1, that's a 4. 4 and 4 cancel. That leaves you with a 1 times that 3. That makes it a 3x. 4 times 3 is a 12. Do not forget the other side. It has to go through all of it. 4 times x, that makes it a 4x. 4 times 5, that makes it a 20. Now, before anything moves across the equal bar, we look at each side, the left side and the right side, and we see what we can combine together. So let's see what we've got. And I like to do the variables first. So on the left side, right, the sides are divided by the equal bar. So on the left side, I have a 3 and a 2x. That makes it a 5x. And then I've got a 4 and a 12. Those can go together and make it 16. Is everyone all right with that? So just combine. Be careful with your adding and subtracting. What's my next step going to be? Okay, yep, 4. That 4x can go over. So that's going to be my next step. I'll move that 4x over. So move that 4x over. And when I move that 4x over, 5 minus 4x, that makes it a single x. You can put the 1 there, but we generally don't. Then we've got a plus 16. On the right-hand side, we still have a 20. How do we finish this question out now? Yep, subtract 16 from each side, and that leaves you with x equaling now what? 4. And that's going to be your final finished answer. How do we know when to stop? We got x equaling a number, or the sides are the same, or the variable is gone. Okay, let's look at another one here. Let's look at 66. Okay, this one has decimals. Now, how do we handle decimals? We're going to handle decimals the same way we would any other number. If we need to, we use a calculator. I'm not going to make you clear the decimals out. I think that's extra work. We have a calculator. We're going to use our calculator. So don't try to clear out the decimals. Some instructors have you do that. I think it's more work than just clearing them out. So 66 here. This one has decimals. And students don't generally struggle with decimals as much as they do with the fractions. And we've covered a lot of fractions, so now we're going to move on to the decimals. Okay, decimals are going to behave just like any other number. So distribute that 0.3 through. If you need to, you can use a calculator. So that's going to be 0.3x. And then we need a calculator, we can use it. All right, so what we have is we have 0.3, multiply that by 12, and that gives you the 3.6 there. Okay, plus 0.9x, and that equals 6. Before we move anything across, these can go together. So 0.3x and a 0.9x. That leaves you then with, adding them together, 1.2x, right? We just add them together. Plus 3.6 equals the 6. And what would I do next here? Yep, we're getting it down now. Subtract that 3.6 from each side. That leaves you with a 1.2x equals, use a calculator if you need to, 6 minus 3.6. That gives you a 2.4, right? Divide that then by 1.2. And what do we get x now equaling? 2. And that's your final answer there. Decimals are not difficult. Use a calculator. Just make sure you don't lose any of the decimal points. It's more a matter of making sure that you're careful when you work them out versus them being difficult. Just don't lose a decimal point. Careful with things. Also notice, whenever I write something out, notice I put the 0 in front of it. I don't just write the 0.3 because you might think that it's 3 and lose that decimal point. So if it's a decimal and it starts with nothing in front, I put a 0. That way it's 0.3. That way I don't accidentally think it's 3. Because if I don't have the 0, see, you'll look at that and you might think it's 3. So always put the zeros in front. That way you don't make a mistake when you work these out. That one gave us an answer. Let's look now at 68. Okay, question 68. 0.04, remember I put the 0 in front there, times the x plus 5. That equals 0.04 x plus 2. First step is going to be distribute through. Now we have a 0.04x, and we're going to distribute that through. So 0 0.04 times that 5 for the next piece. That gives you a 0.2, and that equals 0.04x plus 2. You may have to set it as, I can fix it real quick here. Probably trying to make it into a fraction. Let's see, there is, and if anyone else needs me to, I can usually clear all these out and fix them right. I remember every one of them is different here. Okay, so I can fix most of these. It just takes a minute. If anyone else has that problem where your calculator just gives you a fraction instead of a decimal, just let me know, and I can fix it for you. Okay, we want normal. Let's see if that's going to fix it. No, that's not going to fix it. Just give me a second here, and I'll fix it for you. Yep, no problem. You're welcome. Let's try line. One's a little bit different. Remember how this works here. Okay. That's the contrast. Okay, table. It'll work now. Just took a minute to find it. Yep, try it, see? Because when you multiply through, see what you get. So take that 0.04, and you should get that 0.2. So 0.04. Multiply that by that 5, right? And that should give you, is it working now? Okay. Yep, you're welcome. And if anyone else has a question about a calculator doing that, where it gives you a fraction instead of a decimal, let me know and I can fix it. Every one of them is a little bit different, and I've worked with all the different models, so I can usually fix it for you. Okay, now, what do we need to do next? We need to get the x's on the left, and so we're going to move that over with subtraction. And what's going to happen on this one here? Those are gone, right? Those are gone. So now I've got 0.2 equals 2. Is that a true statement or not? Does 0.2, does that equal 2? No, they're different numbers, right? Not equal. So that's false. So that means this is a contradiction. And we have now no solution. Okay. Let's look at one where we have an identity again. Let's look at one more of these. This one's got fractions again. Well, yeah, I don't think we're doing a fraction. I think we'll just do one that has an identity. This one's got decimals, not fractions. So let's look at 72. I think we've done enough fractions. We'll do one with decimals. So 72. 1.8x plus 1.2 equals 0.9 times 2x plus 3 minus 1.5. So first things first, distribute that 0.9 through. Stop at that 3. So distribute that 0.9 through. So use a calculator if you need to. We've got 0.9 times that 2. That gives you the 1.8x there. And then we've got 0.9 times 3. Okay, that's going to give us our 2.7 minus 1.5 here. And the other side is 1.8x plus 1.2. what's going to happen when we combine terms together? On the right-hand side, those can go together, can't they? And when I do that, I get 1.8x plus 1.2 on the left. On the right, I get 1.8x and 2.7 minus 1.5. That gives you also a 1.2, doesn't it? Now, what do you notice about these? These are exactly the same. When they are exactly the same, we have a special name for it, and that's an identity. Okay. And what's your solution set? All real numbers. So it's an identity, and your solution set there would be all real numbers. So is everyone okay with how these are working? Let's do a couple more just to make sure we understand how all of these are going to work out. So those are working with fractions. I'm going to create some more. I'm going to create some more complicated ones for us to go through and work out. So we've seen all the basic problems. Let's do some more of these. Once we are sure we understand these, we'll take a break, we'll come back, and we'll look at some applications. But I want to solve some more just to make sure we know how to do these. So I'm going to make these up myself. And we're just going to solve this one. This one has lots of things going on. It's just the same as what we've done, just adding more to it. So I want us to work through this one. And the first thing I always do is I always try and clear out those parentheses. So that's the first thing that I'm going to do here. Is I'm going to clear out these parentheses. Now I made this one on purpose so you would see the negative here. Okay, if it's a negative out in front, I always like to circle it, and I distribute it through. That is going to change my signs. So let's distribute this through and see what we get. We have a 5, and then we have a minus 3x. Distributing through makes it a minus 7. And then we've got a plus 5x. On the other side, the 2 is going to be distributed through. And again, we stop at that 7. So that's going to be an 8 distributing through. 2x minus 14 minus 8. So all the parentheses are now gone. Okay, before anything is moved over, what do? Combine like terms on the left and combine like terms on the right. So never move things over until you've combined. Combining always goes first. So let's see what we get when we combine here. Minus 3x, positive 5x. Those go together. And that makes it 2x, doesn't it? And then we've got 5 and a minus 7. Well, that leaves you with a minus 2. So the left-hand side is 2x minus 2. On the right-hand side, the only variable that we have is that 2x, so that's there. And what do we have number-wise? We have an 8. We have a negative 14 and a negative 8. Well, the positive 8 and the negative 8 can cancel themselves out, and that leaves you then with simply a what? Leaves you simply then with a 14. Okay, what do we now notice? Both sides have what? 2x, don't they? So what's going to happen when I move that 2x over? I've now got something that doesn't work. Right? Because negative 2, does that equal negative 14? No, can't happen. So this is false. And what kind of equation is this? This is a contradiction. And it has no solution. That That is the Greek letter phi, okay, lowercase phi. That means no solution. It just means no number works because it's false. Let's try a couple more. Let's go back and do another fraction. Because we always struggle with fractions. So let's do some more fractions. Okay, so this one's got lots of fractions in it. And always, always get rid of those parentheses first. So that's the first thing that we always, no matter what, do. Parentheses go first. So distribute through. And the fractions, if you struggle with the fractions, write them out to the side. So that's going to be 3/4 x. And if you struggle with these fractions, write them out. We've got 3/4. I'm going to multiply that by a minus 3/7. Okay, we're multiplying, so we, again, do not have to have a common denominator. We multiply across. So 3 times a negative 3, that leaves you with a negative 9. And 4 times 7, well, 4 times 7 is a 28. So that leaves you then with a minus 9 over 28. On the other side, we have a 5/7 x. Then we have a plus 8x. And then we've got 8 times a negative 1/2. And if you need to, you can make that over 1. Those cancel, and that leaves you with the 4. So that's going to come out to be a negative what? 4. Because what's half of 8? 4. It's negative, so that's why it came down as a negative 4 there. Okay, we just multiply those together. And anytime you need to, you can always put that as a whole number over 1. Next, clear our fractions. What am I going to use to clear out all of our fractions? This one's a little bit more difficult. Okay, let's think about what we've got for our denominators here. We've got a 4, we've got a 28, and we've got a 7. Now, where I always begin is what's my largest denominator? Largest denominator is 28. So let's see if it goes into all of them already. If it does, then it's going to be easy. If it doesn't, we'll have to do more work. But let's look at that 28. Okay, does 28 evenly divide by 4? Yes. Does 28 evenly divide by that 7? Yes. So already I don't have to do any other work. My least common denominator is going to be a 28. So everything now gets multiplied by what? 28. Clear our fractions by dividing and multiplying. Divide by the number below, multiply by the number on the top. So 28 divided by 4, 7. 7 times that 3 makes it a 21x. Next, 28 and 28 cancel out directly. What's left over? Negative 9. 28 divided by 7. Okay, 28 divided by 7, that's a 4. 4 times 5 makes it a 20x. Nothing is going to go here, so we just multiply. Okay, here we'll need a calculator. If we've got 28 times the 8, that makes you have a 224x here. And then we've got 28 times a negative 4. We know our answer is going to be negative, and that's going to be a negative 96. Is everyone okay with that so far? Take your time, use a calculator. Don't ever feel like you have to do things mentally. If you're not comfortable doing things mentally, use a calculator. I would rather you use a calculator than make mistakes. The x's can go together. So adding those together, that gives you then 248x. Or sorry, not 48, 44. My mistake there. Oh, let's see. Did I multiply wrong? Maybe I might have used a 3 instead of a 4. So let's see. 28 times that 4. Sorry about that. 112. I think I probably used a 3. My mistake. Sorry about that. Should be 112. And yeah, if I make a mistake, be sure and tell me. You know, I try not to. But once in a while I do something like that. I was probably thinking of the 3 before. But I multiplied everything by that 28. And 28 times that 4 makes it 112. Now we're going to put our x's together. So we've got 20 and 224. Those go together, and that makes it 244. And then we've got a minus 112 here. And then we've got a positive 21x and a minus 9 on the other side. Now we can finish it. Nothing else goes together. So now's the time to move things across the signs, or the equal bars. Move the signs over. So that's a positive 244. So we're going to use a minus 244x. That's going to take care of that. That's going to go with that 21. And again, if you need to, use a calculator. 21 minus 244. That gives you a minus 223x. And then we still have the minus 9. And that equals a minus 112. What are we going to do next here? What would be my next step? Yep, and how would I do that? Yep, add your 9 to each side. And that gives you a minus 223x. And the other side, I believe, is 103, negative 103. So we've got 12, it's 9, yep, minus 103. And can we finish it out now? Should be pretty easy to finish out. Divide by a minus 223. And let's see what we've got. What do we know about a negative divided by a negative? Okay, negative and negative makes it positive. And let's check and see if this comes out to a whole number. I don't think that it will. And it does not, right? It comes out to be that. I don't think this is going to reduce down anymore either. Negative and negative makes it a positive. But we can check. Let's see if a 3 goes into these. 103 divided by 3. I don't think a 3 will. Nope. I don't know of any other number that will. We can try a 7. 7's not. No other number is going to go through. So what's your final finished answer? It's not going to reduce down anymore. So your final answer would be 103 over 223. Let's take a short break. We'll come back and we'll look at the applications next. So let's meet back here at around 9:55.